of two factors, because we can see we have x cubed here and x squared here, which means there's a common factor, which is x squared. And when we factorize x squared, then we have x squared into x minus 2. So this function, fractional function, has a denominator that is a product of two factors. One is x squared, another one is x minus 2. And this is similar to what we have had up there. We have x squared, and x squared should give us two terms, a and b. So we can rewrite this in partial fractions as we have c over x minus 2. That takes this factor. Now the factor x squared can be, we could have ax plus b over x squared. Or we subdivide that as a over x plus b over x squared. So we can have ax plus b, because these two fractions, if you combine them, making x squared to be the LCM of the denominator, you will have ax plus b over x squared, which is allowed. Or you can decide to make integration simpler. You subdivide and write it as a over x plus b over x squared, not bx. It is just b, because combining this will give us ax. So subdividing, it's not bx. That would give you a wrong function, which is not the same as what we have there. So from here now, work out the value of a, b, and c, then substitute back here and integrate. So, and the value of a is -2, b is -2, c is equal to 2. And when you integrate, you get the answer below. So we can apply the same knowledge here. 13x plus 7 over x minus 2, sorry, x minus 4 into 3x squared plus 2x plus 2. The factors here are x minus 4, and this is not easy to factorize, so we have 3x squared plus 2x plus 3. Now for x minus 4, we'll have a over x minus 4. But for 3x squared plus 2x plus 3, we have x squared. We expect the denominator to have a power that is less than 2 by 1. And we have bx plus c. The power of the numerator should be 1 less. So we have bx plus c. Then from there, you solve for a, b, and c, and integrate to find that. The same here now. We have 1 over x into x squared plus 4 squared. Now it is the same as the case where we had x squared. We are squaring a factor. This factor is x squared plus 4. It's being squared. So we have two factors here, x and x squared plus 4. But x squared plus 4 is also squared. Hence, for x, it is a over x. But for x squared plus 4 squared, it is like if we make this be y, it is y squared. And we would have b over y plus c over y squared. So it is b over y over plus c over y squared. But remember, this is x squared also is here. So whatever is under above x squared plus 4 must also bear a degree, one less degree than x squared plus 4. And that is bx plus c over x squared plus 4. So this is like y. Then this is like y squared. So y squared also has the same denominator, sorry, the same numerator, bx plus f. Then the next procedure is the same. Find the values of a, b, c, d, and f. Substitute and then integrate. So here we are lucky, c is 0, f is 0. You end up with only b and a. Then do the integration. It's indefinite integral, so you add c. If we have definite integral, then we substitute the limits that are given. But here, because it is indefinite, we just add c. And that applies. Now, in this case, we have x squared plus 1 and x plus 1 cubed. So what we have learned here applies here. But now this is cubed. And here we have x to power 1. It is not squared. So assume this is y cubed. That would give you a over y plus b over y squared plus c over y cubed. Because it's cubed, we expect 3 of these values, the numerator. But the first one is over x plus 1. Then the next one, x plus 1 squared. Then the next one is c over x plus 1 cubed. And it's not ax because this is x to power 1. The one we have just done, we are having bx plus c because the x there is squared. But this one, it's x to power 1. So a is multiplied to x to power 0. Any number to power 0 is 1. B is the same, x to power 0. C is the same, x to power 0. And evaluate the values of A, B, and C, then integrate. And you can now try these examples here as practice exercise for you, and you can get more also.